Great to see you all. We're gonna small group today, so this is great. I hope don't be afraid to ask a lot of questions. Can give you a lot of attention, our individual attention. And we have about an hour-long presentation. This is our wood fiber 101 series, and later on this year we'll be breaking out into a little bit more specific topics of interest. We'll still do the 101, I think, quarterly, but for right now we have Jason Todd, and we'll introduce ourselves in a little bit. Jason Todd, Claire Donnelly, and I'm Edith Galler. And Jason will be running the slides. So do you want to
get that started?
Get that started, sure. And just as people are coming in, we'd love to hear from you. Who are you? And how familiar are you with wood fiber insulation? So depending on the answers that we get from you guys, and just feel free to type it right into the chat. Are you a builder contractor, architect, specifier, etc.? We can try to tailor our conversation a little bit more towards who's in the room. So we'd love to hear from you. Who you are and how familiar you are with wood fiber. And I guess I don't see too many people still coming in, so maybe I'll give I guess we'll do introduction.
Edith froze on my screen. Is that my computer?
I think that Edith might be a little glitchy today.
Yeah.
Edith, do you want to try introducing, since you started the conversation, and maybe let everyone know where you've come from and how you got to TimberHP?
Sure, absolutely. So I've been with the team for a couple years now, and I come from an architecture background, and I was working with one of TimberHP's co-founders, Matt O'Malley. He's a passive house architect in Belfast, Maine. And we're really trying to tackle the question of how to drive down operational carbon in our built environment. That's one of the things we tackle as passive house architects. But as we were getting deeper into solving those problems, we were understanding that by adding more insulation, we are actually driving up the embodied carbon in our buildings, because a lot of the insulation materials we have are high embodied materials. It's like foams and rocks and steel slag and basalt and everything like that. So really started to pivot in the last 5 years to focus on embodied carbon and how we can tackle that. And material science chemist Joshua Henry, and they asked this innocent question: why isn't wood fiber made here in the US? And so here we are today.
Excellent. We got most of that, Edith. It sounds like your connection's a little spotty, so hopefully everyone can hear us okay. I believe it might just be we're doing a little bit of remodeling here in the marketing office, so
Oh goodness, are we losing everybody? I can introduce myself. I'm not in the office, so my internet is strong. And also for those of you who have, there's been a few late joiners. Thank you for coming. We just asked people sort of what your area of specialty is, like architect, builder, designer, supplier, manufacturer, wherever you fall in there. And then just on a scale from 1 to 10, how familiar you are with wood fiber. So like 1, 0 being you've never heard of it before, you're not sure why you're here, and 10 being like you should be giving this presentation. So if you guys want to just pop that in the chat as we're giving introductions, that would be awesome. And I'm Claire, I'm the senior marketing coordinator. I've been at TimberHP for just a few months. So I've been in like building science school deep dive, which has been awesome. I come by way of marketing and PR. So it's been really fun to dive dive into wood fiber with the team. I've drank the Kool-Aid, as they say. And thank you all so much for joining us.
Thanks, Claire. My name is Jason Todd. I'm Director of Building Science and Industry Support. I've had a couple of different roles throughout my career around the building industry. Was spending some time with Opal, same organization that Edith had mentioned earlier in her remarks. A little bit more research oriented there, previous to working with the architecture firm. Spent some time with green fiber and market development, and also covering a territory here in New England. Training, education, efficiency Maine, and other state program support, but very excited. I don't think we get the opportunity to see new material in the insulation industry, and very excited to bring this technology here to North America. And also, I'll put a couple more team members on the spot if they care to chime in. We've got a couple of new hires here. Very happy to introduce maybe Scott, if yeah, why don't you come over, since we don't have you mic'd? So I have you hot mic'd. I'll slide over.
Thank you. Thank you. Hey, thank you so much for taking the time today to join us. I joined on Monday after a 5-year Huber Engineered Woods, worked with them as a business development manager throughout the Northeast, and I'll be taking a similar role here at TimberHP, and super excited. As Claire mentioned, I mean, and Jason as well, the product is just absolutely awesome. Right product, right time, and very excited to get going. So I'll turn it back to Jason, and hopefully you'll enjoy the content today. Thanks for attending.
Scott. And we'll keep things moving along here. We have also hired Alex. He's joined us on the call as well. Drinking from a fire hose these days and doing a wonderful job inside sales. He'll be assisting myself, Chief Marketing Officer Scott Dion as well. As we start to grow, it's been sorely needed, and glad we could bring him on as well. Thanks, Alex. We'll jump in and get moving. I know we had a few other people joining, and just as Claire had said before, we're happy to know a little bit more about you as well, and we'll look forward to questions, conversation towards the end of the session. Feel free to throw things in the chat. Feel free to throw in where you're coming from, what part of the industry you come from, and your experience with wood fiber on a sliding scale of 1 to 10. 10 being extremely familiar, and I will step aside. But glad to have everyone here today. We have gone to market with a branding message that is near and dear to all the things that we believe in, very close to our heart. And healthy planet, healthy people are paramount, very important things. But before all of that is the performance of the material. And we talk about the building envelope, we talk about the metrics of thermal and acoustic, but then also whether or not a product is vapor open, all of these things that we look in high performance buildings, whether it's a code built home or exceeds it greatly. High performance is first and foremost, but we can't neglect to acknowledge the importance of carbon emissions, of course, indoor air quality. All of these things have to do with healthy planet and also with healthy people. On that performance front, there are plenty of things that are listed here on the left that we'll get into in the presentation. But what we're hoping to introduce to the market is something very conventional, something that is very familiar. And as you'll see, I believe a drop-in replacement for other materials on the market currently. We do have some nuance to this. Just recently, we've gotten a little further along in our production schedule. We will be producing material the end of Q1 into the spring. We should have all of our certification and an evaluation service report done early part of summer for the timber fill. And by the end of summer, we should be looking at timber bat rolling out, soon following on its heels, an evaluation report for that material, and getting into the fall, releasing our initial board product, which of course will also go through that same process for valuation services. And you'll see that towards the end of the year, moving into the next year. This is a new product here in North America, but there are some early adopters that have been using it for quite some time. It is well established in the European market. It's been some 20 years. A number of manufacturers, Styco, Gutex being some of the more familiar. And those of you that are familiar with wood fiber are probably seen or even used this material. Most likely the board, not as much of the loose material has been brought in, and some of that is with the fact that on a good day, it's German air that's being transported across the ocean. It's very light material, doesn't ship well, and that's rather expensive for air from Europe. It's a significant industry, 800 million and growing. We'd expect to see that grow further. There's an extremely high demand overseas right now. Some of that's the carbon story. Some of that's the performance of the material. As a former installer, someone who's handled and unfortunately breathed some of the material out there on the market, wood fiber and wood dust is much more a comforting material to suck into your lungs by accident because the respirator or the mask is off, or you're just in a place that's really dusty from it getting kicked around. This, I think, is in high demand overseas. It's one of the reasons why maybe these manufacturers are not looking towards this market, but they've also been very supportive. I think one of the learning curves that any insulation manufacturer has is to understand their market well. Something that we here at TimberHP feel that we've got a firm grasp on with the expertise. It continues to grow every day. One thing to note about the European market and the material, certainly what's been brought over here stateside is expensive, and some of that's the shipping costs that are incurred. But by nature, the cost of wood chips is much higher than it is here in the States. Certainly here in Maine, where we're seeing a decline in the paper industry, the same wood chips that are being used in that industry are what we will be using in manufacturing our insulation. And the energy costs are also much higher overseas. So it is sold as a 20% premium in the market. And it's a market that doesn't carry as much wood frame construction. That's increased, but there's certainly a much older market there, existing masonry building. And it's exciting to see what we can do here in the States where stick built is so much more prominent. Again, to that premium message, the environmental and indoor air quality and the health concerns are really what are being promoted and sold, and we also will be doing the same, but not sacrificing the performance of the material or the availability and the accessibility of the material as well. Cost competitive, cost effective, all of these things are very important. We would love to be the stealthy, carbon negative, high indoor air quality material that gets put in place because it's also the best fit for the job. There's a fairly straightforward process, and we'll talk a little bit about that as we get into each individual material. But in essence, we're looking at a very clean softwood, spruce, pine, fir predominantly material as our base. Significant decline in the paper industry here and in other parts of the United States. And we will be able to fill a void that has been left from that industry. Big part of the chips as a byproduct of another industry in that decline is that it's actually a revenue source for them. Here in the state of Maine, we've lost 6 paper mills in the last 10 years or so. And with that, for the lumber mills that exist in this area and in the region, a revenue stream, and honestly, a liability as they build up chips that they've gained from their process. They lose the ability to move and adapt as quickly in the market because it becomes a burden, and also certainly the cost there. All of the material that we are looking to use is a focus on forest certified, FSC certified material. When it's coming as a byproduct, that's almost by default. But as part of good forestry stewardship, we also expect to see some material chipped that will be used. It was just good housekeeping, weeding the garden, if you will, in good forest practice. One of the most prominent questions we get, aside from fire, water, and bugs, has to do with pricing of material. And as I suggested, we are able to be much more competitive because where we're coming from with our raw material and cost and our energy. You may hear it in the background. I'm looking out the window at the river. Kennebec River is pouring by along our building, and we are behind the meter, direct from that hydro right there. Our utility costs are a little bit lower because of the industrial nature and the agreement of the mill here. It's certainly one of the benefits, but it's also great to see exactly where that power is being generated, so close right here. We expect parity in cost, very competitive with all borate cellulose, the premium cellulose that's available on the market currently. The bat and the board, a slightly different story, but also a very favorable one. With timber board, we also expect to be very much the same with what's available on the market for XPS foam. Maybe even a little bit better depending on the pricing that particular day. It seems to fluctuate quite a bit. Less in mineral wool, and with that, somewhere between fiberglass and mineral wool. Timber insulation, timber fill insulation, our first product that we are rolling out is, it's a great place for us to start. It's the beginning of our process as a whole, and we've touched on how it gets from chip to the final bag for the installer in a bit. But what we've discovered from the material we've imported and done some testing in our initial look at a cellulose-based product that does not go through the paper making and recycling and recycling and the debris issues behind that, is that we will be competitive in price, comparable in our value, landing at about 3.8 per inch. And I think you'll see maybe even a little bit more competitive in the installed cost, because the densities for wood fiber in the wall can be lower than what's installed for cellulose, and the coverage seems to be free and clear of things getting in the way like debris or plastic, other materials. Excellent coverage in the attic, less downtime, machine maintenance for the installer as well. Same kind of treatment if you're familiar with cellulose insulation, boric acid. The advantage to our process over traditional cellulose manufacturing is that paper is ground up and a dry powder is added. The borate salts are added. It doesn't stick very well that way. We process with steam to soften the chip, and then we refine it, and essentially a plate mill, if you will, grinds that into the ideal fiber size for us. In that process of moving it to the bag, we then need to dry the material out. We have flash tube dryers and very tall cyclones that are being installed and staged currently as we talk. And in that process, we add liquefied boric acid. It's fairly benign salt. It's been used as an eye wash in the past. It's Boraxo laundry booster you can still find on the shelf. fairly safe material to work with, to install, to have in your home, and some really excellent benefits when it comes to fire retardancy. Expect to see a Class A product where a low flame and smoke development according to that standard. Relatively straightforward and clean, effective material timber fill insulation. We use that same fiber stream for a timber bat. We add some bicomponent to that, and we essentially bake it in the oven. I kind of think of this as it's the world's largest easy bake oven we've got built here. You might also compare it to a pizza oven, if you will, where you've got a conveyor belt or a toaster in a hotel room, and moving through that process. Set the right size for the bat, brought down in a press, and then the bicomponent is melted into the fiber and creating this structure. Very rugged, resilient, but still flexible material. It's a real pleasure to install. I enjoy cutting it. The firmness of it allows you to make some nice, real clean cuts. And we've been exploring tools used overseas and tools and options that we can use here. Can be cut with the right blade, with a hand tool very easily. Can also add those to conventional carpentry tools out there and cut and fit fairly quickly. It's a sample of bat. We like to play with fire. We're doing that less and less now that we have a safety manager here on the campus. But at least we've got the video, and all precautions were taken. Fire extinguisher and a steel top plate there. But you can see that with this product, the bat is also a Class A because of the borates added, or in the European case, ammonium sulfate. You get some charring. It extinguishes very quickly. It's very little development of smoke. Timber board's a little bit different. The fiber stream is essentially the same at the beginning, but then the process changes slightly with a finer grind. It's just you can see it in the board itself. It's a little more refined, if you will. It allows us to blend this with MDI, a little bit of paraffin. MDI or PMDI, you can consider a Gorilla Glue would be a familiar application. It's well used in many applications in the industry, as well as other areas. The thicknesses of this board, it can be less than an inch, but we see 1 inch up to as much as 9¼ inches. You've got inch and a half boards in the example, maybe 5½ inches. So we can get a pretty dense, pretty thick mat of material, and would see that great in wall applications and roof applications. Depending on the density of the material, that will influence the R value. R value has to do with the thermal resistance and how much air is entrained in the material or captured, for example, maybe in a window pane that's air in the middle there. So the density plays into the R value, but expect 3.4 to 3.7 depending on the board. In addition to the MDI, we also have that paraffin wax, and that wax helps the board to be hydrophobic. We've got some interesting displays here. Something we have in our Mad Lab here in Madison on the right-hand side. If you were to set up a rain screen, add your vented siding on the exterior of that, and then the siding on top of it, but that siding would fail. It probably wouldn't look quite like this with it pouring down the wall like that, but if it did happen, rest assured that water would shed quite quickly because of the binders and the paraffin that are added. All at the same time, that remains very vapor open. It allows for a flow through assembly, which we feel is really important for building durability and the material durability. And you can see in that top left photo above the College of the Atlantic build happened recently in Bar Harbor, Maine, significant project that utilizes European fiber. The crew found that those scraps that were cut off, that weren't going on the walls, actually made really good steps. And you can imagine a muddy job site and a number of people going in and out with work boots. Very, very durable, rugged material. Like I said, we do like to play with fire a bit. We've got a couple of products you'd find in the industry. EPS, maybe not so commonly used, but certainly in SIP panels, in some foundation work. Even if you add chemicals to increase the fire retardancy of a foam product, in the end, it is still foam. Some people actually, Joe Stebrick, who might be joining us in a couple of months' time to talk about flow through assemblies, I believe calls foam board sheet napalm. Pretty noxious material, but you can see that with some temperature applied to it, it just melts. Whereas the dense board that is really only a class B, just over the line as far as flame development and smoke development, takes the heat just fine. It chars, that pyrolysis builds up. It's a protective coating, if you will. This is the advantage of wood and mass timber. Very flame resistant because of that density. Edith taking some risks here, grabbing the board on fire. But in the end, the point of fire safety, and the standards have to do with the time needed to get out. And with all of these other products, time is critical because what often gets you is the chemicals and the smoke that comes off of materials, not necessarily that time. It's a significant factor. As we go to market, Alex and Scott and myself and the other folks on the sales team, we're not just about sales. We are about building envelope experts. We call that our Bs. And fits very well with our logo, the beautiful logo that Edith has come up with, and Claire has been promoting and spreading some of the best practices that will be promoting and supporting folks with. The importance of our material out there in the market as a drop-in replacement is a big part of that. The familiarity is something that we are going to be promoting and supporting folks with, and recognizing that this is a comprehensive above grade solution. There will be some applications in basements in some parts of the country for sure. But that's a design or a install judgment as far as how well dry it is. I don't see it being a problem in a relatively dry basement. I also don't see too many of those here in the Northeast. So we're going to focus on walls, roofs, ceilings, floors, but be an option in some cases. But it's not a board like a foam board that would get buried under a slab, anything along those lines. You know, we've got a very long list of products that we'll be rolling out. Our initial product focus on single family, some light commercial, multifamily under 4 stories. Predominantly, we will expand that as we get the product out in the market and get into more testing. We are certainly going to be generating acoustic testing as well as fire rated assemblies. The greatest confidence of being able to produce 1-hour firewalls or even greater compared to other materials on the market. 2-hour firewall in, say, townhouses or in some multifamily applications. That's critical. Also, mass timber, CLT, type 4. We're looking at residential type 5, type 4 mass timber, some type 3 buildings when we get into the 4 stories and under in the commercial realm. I touched on this briefly before, the vapor open flow through assemblies, the stuff that Joe Stubrick will be presenting in a couple months' time. Real critical for building durability. High perm ratings on the wood, fiber, and board allows the material to dry. Most parts of the country, or many parts of the country in the heating part of the country, are looking at code improvements or progression towards newer codes that are requiring continuous insulation on the outside. This certainly helps, but we really feel that having a vapor open material as part of your continuous solution is the safest and most durable method. If you are wrapping that building in foam, you're still shutting down vapor flow one direction, and that means it has to dry back to the interior. With an assembly and a little bit of a throttle, might be OSB, might be a membrane, that vapor can escape, whether it's coming from water, bulk moisture from the exterior, rain, snow, or from the heating, the cooling, the cooking, showering, all of the internal dynamics of a home that can generate moisture and find their way into the wall. Insulation for all seasons. Everyone's familiar with R value. It's a metric we compare products with, and it tells part of the story. Coming from building science over the years and focused on the building envelope, this is how I've always thought about it. But what's interesting and new to me, and I think to the industry as a whole for the most part, is the idea that not only is a high R value or low conductivity of a material important, but the heat capacity makes a difference. How much can that material actually absorb heat before it passes it through the envelope? And we see a certain amount of heat protection because of the high heat capacity or ability to act as a sponge. That's very important. There's a display here shows 3 different board products, their respective R values. The density of all of these are slightly different. Certainly the heat capacity is different. Wood fiber has the highest heat capacity of any insulation on the market that I'm aware of currently. A very competitive, comparable R value to mineral wool, and a less so when we start talking about foam, the higher R value. I'm going to run this video here, and you'll see on the bottom of all 3 of these thermostats, we've got a probe sandwiched in between the 2 layers of the foam. And when I get this to run here, or not, see if I do it from here. You'll see that temperature rise, and in particular on the foam side. This is the highest R value material of the 3. We top out at 125 degrees within 10 minutes of that heat being applied. You can imagine this assembly being a roof or a wall. And let's say that 10 minutes is more like hours. And in that time, it's still 80 something in the core of the wood fiber assembly. We've topped at 120 plus. That's inside your house. 115 on the rock wool material also has made its way in. It's a stark difference in materials and the effectiveness of reducing cooling loads and increasing comfort in the home when you start talking about wrapping a home in wood fiber, the same material we are often building our homes with. touched a little bit on vapor open assemblies, the importance of good indoor air quality. The wood fiber itself also does, like cellulose insulation, manage that moisture. It absorbs it and redistributes it. It holds it and lets it back into the environment as the pressures change over time. That allowing for moisture that does build up to be released means that you're not going to have anything growing in the walls. You're not going to produce mold or mildew. These are critical areas when we talk about allergies and respiratory issues. We've also done some initial testing and found on the acoustic front a very comparable material with some of the best on the market. In some cases, sound transmission class ratings that are better than other products out there. And we will have a list of materials for not only just wood frame, but also steel frame assemblies. When we start talking about commercial and code, STC 50, I can get you that in a 2x4 wall with some resilient channel in the bat or the fiber. And again, all of these great attributes and product merits, in the end, it's 90+% wood fiber. Toxins are not an issue or concern. Irritation is not a concern. It's a much more agreeable and easy material to handle and work with. Those that are familiar on the install side or the distribution side on the call maybe have past complaints along the manufacturers when we talk about recycled products, cellulose in particular. Not a lot of cleaning up of that material, that raw material, and unfortunately byproduct, strapping, rubber gloves, all sorts of things get into that can affect the coverages, the installability, the usability of the product. It's very important that those that are installing this material are also healthy, safe, experience good indoor air quality, and can do their job as effectively as possible. When you are binding up the augers on your machine, that slows you down. That's increased maintenance. Spray foam is wonderfully high R value product. It goes in well. It's great when it doesn't, and that material isn't blended right in the field. It's a toxic mess. And of course, rock wool, great for fire protection, and leaps and bounds above the rest of the wood framed house itself. Maybe a little bit of overkill in most applications, but steel, slag, basalt, byproduct of the steel industry. It's also a skin irritant, respiratory hazard. And we're going to shoot this over to Edith if we can hear her. All right. And maybe talk a little bit about the other merits that we have around carbon.
Yeah, thank you so much, Jason. And first of all, apologies. I had some connectivity issues that reared its head just as we started this presentation. So hopefully you can hear me all okay. Swap computers.
Sounds great.
Okay, super. And I want to leave time for questions at the end. So I'll try to move through these pretty quickly. I know we do have some architects and specifiers here. So the good news is in next month's workshop on February 16th, that's the third Thursday is when we do these workshops. I'll be doing a presentation with Jacob from the Beam Calculator, and we'll be doing a deep dive into embodied carbon and how to account for all of that in the built environment. So flag that one, and you can find all the events on our webpage as well. But I'll breeze through this and then join us next month if any of this piques your interest. So you've all seen this chart a million times probably, but you know, the built environment accounts for a huge percentage of the energy consumption in our world at the moment. 39% from buildings. A big chunk of that is from the building operation. So operational energy, what we use to heat, cool, electrify our homes. And then a smaller slice right now is the impact from materials and construction. So that's the embodied energy that we talk about. So we've really focused on this chunk, the operational energy chunk. And I mentioned it briefly in my intro, but again, I think I was cutting in and out a little bit. But Jason, I requested control. Okay, I do have it. Never mind. Ooh.
There might be a little
All right,
delay.
there we go. All right, little delay, but anyway. Yeah, there's increased discussion, worthy discussion around embodied carbon these days, and we're gaining new tools by the day to be able to really measure apples to apples the different materials that we specify or utilize to build our homes and buildings. And so this just has to overview of the life cycle analysis here. So we've got the product stage, the material supply, transport and manufacturing. That's a big one. Construction stage, then bringing the materials to the site and all the energy required to construct and install the materials. Then is the use stage, and that's the operational energy that we talked about, but also includes, you know, like the maintenance and repair and replacement and refurb of the materials. And then the end of life stage is this question that we get a lot, like what happens at the end of the life with the building. And when we talk about wood fiber, there are some really promising and interesting potentials there, around there. So as we're getting better. We're starting to really be able to tackle this operational energy issue that we've set ourselves up with. So our energy supply is becoming much more efficient, and we are insulating our homes a lot better. So we're driving down that operational energy. As I mentioned, my background is in passive house architecture, so that was really our focus, right? Is to, you know, almost triple the amount of insulation we had on our on the exterior of our buildings, and use very efficient systems in order to, you know, get a 90% reduction on operational energy. And we were doing so with higher embodied products. So we were super insulating our buildings with foam and rock wool, the materials that were available are available, right? So, and those are pretty high embodied carbon materials when you think about it. And so we were just kind of pushing this issue down the road. We were tackling operational energy, but adding more embodied energy. And so the offset, the payback for adding those materials was like 8 to 10 years down the road, right? If we use foam. And as Matt O'Malley, our co-founder, will say, we don't have 8 to 10 years to wait or to push this issue away. So this is just a slide from AIA 2030 that is highlighting the need to really focus in on embodied carbon more than anything now. In our buildings, these are some common high embodied carbon materials that are found. Concrete, of course, is the big one. And there are some gains we've made there, and alternate products that we can use. But insulation is number 2. You know, we're, as I said, the materials that are available are very high embodied carbon. And so if we bring wood fiber, a carbon storing material, into the picture, we're able to right out of the gate have at least, you know, a 16% or more reduction in our built environment. And I should just mention that we'll be doing LCAs on all of our products so that you all can have that data. But we need to be, we need to complete a year's worth of production in order to have those numbers for this site here. We have some preliminary numbers from our European counterparts and the products that we've been able to source from Europe. And it's looking very promising, but definitely we're doing everything we can to get our own numbers from this site as soon as possible. So these are the issues we have with the state of our insulation scene at the moment. It's dominated by foam plastics and fiberglass. And as you can see here, it's just kind of laying the most utilized products up together. This was done with Tally. Tally is the LCA tool that we used in the office, and the wood fiber from Europe is even, it's storing carbon right out of the gate. And if you opt for foam, you're running into some performance liabilities, as Jason was mentioning, around trapped moisture and flammability, but also you're, really increasing the embodied carbon in your building. I'm just gonna fly through the rest of the slides here so we have time, but one of the questions we get a lot is like, well, isn't cutting trees not a good thing? We want to grow more trees and sequester more carbon. And while that is true, absolutely, we here in Maine are in the midst of an incredible wood resource and a huge amount of sustainably forested lands. And so we can support that sustainable forestry by providing a market for those lower grade culls, or, as Jason said, the weeds that you're taking out of the wood so that your higher value timber can grow up and sequester even more carbon. So it's kind of like we'll be harvesting, or, the foresters will be harvesting some of those culled trees in their teenage years, if you will. And so they've already had a chance to sequester and draw in quite a bit of carbon. At that point, we can turn it into a stable building product that will live in the built environment for the lifespan of the building, and potentially, hopefully, much longer as we sort out the end of life recyclability part of the equation. And if those culls are, cut and left to just naturally decompose in the woods, we've all seen, you remember the carbon cycle story from junior high. Some of that carbon goes back into the atmosphere, or most of it does. Some of it goes back into the earth. But what we're seeing out in West is that they don't really have a good market for those lower grade residuals, and the slash is being left in the forest, and that, of course, is providing a huge amount of liability around forest fires. So being able to provide a meaningful market for these wood culls, as well as the residual wood chips from the lumber industry. So those are our two fiber streams, if you will. And in the next 5 minutes, I'll just do a couple of quick case studies. Right here in the Madison Mill, Opal Architecture and Opal Build, they did a prefabricated CLT and wood fiber insulated school building, a little annex for a school building in Belfast. So this is wood fiber product from Europe, got it shipped over, and we prefabricated panels right here in the Madison Mill. And put a bunch of sensors in the wall. So, we're really trying to explore how much wood can we get into our buildings. So these all wood assemblies is something we are trying to encourage and explore and investigate and really test, right? So Opal has been doing a great job there. And we're working with the University of Maine in Orono. They're the ones monitoring the sensors in the wall. And let's see, so a huge amount of wood products in this building using CLT and quite a bit of wood fiber insulation. and looking at the embodied carbon numbers here, with the stored carbon in the wood products and the rest of the embodied carbon in the other building materials, we come to a net 11.2 tons of CO2. And that's about, that's a fifth of the national average for educational buildings, institutional buildings. So pretty cool stuff there. Concrete, even though it's a slab on grade, that accounts for almost 60% of the embodied carbon of the building. And the wood products is 51% stored. Pretty cool. And then I noticed we have someone joined us here today. Kat, I think you said you got to tour this project. It's down in Connecticut. This is another CLT prefabricated building. Again, just trying to figure out if we use all wood and looking at the numbers, where do we land? What's our carbon payback? Can we encourage this sort of thing? Is it a viable model? And so we have wood fiber insulation outboard of CLT walls and wood panel exterior siding outboard of that. Let's see. Again, I'll just kind of breeze through here, but we get to store quite a bit of carbon with our wood products in this building here. And all other building materials with around 79 tons of CO2. So this includes a single family house and a garage. So 23 tons of net embodied carbon in the building. And we are also able to utilize solar tiles on the roof. So this is where we combine the picture with operational carbon as well. So we have a good sense of our embodied carbon. We also assess our operational carbon. So we've taken into account everything from space heating, plug and lighting, plug load and lighting, water heating, and even charging the family Tesla car, right? So this is on an annual basis. We can gain about 3.4 kilograms of carbon equivalents from our solar tiles. So we're actually operating at a net negative annually. We are producing more energy than we are utilizing every year. And so when you look at this picture on an annual picture, how many years does that take to actually offset that original embodied carbon from the building process? And so every year we nibble away a little bit of that initial embodied carbon, and we have an 8-year payback. And if we had used traditional construction materials, even if we were producing more energy than we are consuming, I think this would be a much greater number. So probably double the payback or more. So this is really starting to solve the issue of embodied carbon quite quickly, I think. Here's some glamorous shots of the finished product. And yeah, I just love the interior of, the CLT structure. It's just the panels themselves and unfinished. Or I think there's a slight pickle stain on the inside, but very warm and cozy. A lot of folks have questions around, testing and our certifications. And Jason, you're welcome to pop back in and speak about this a little bit if you'd like in the last few minutes of the presentation. I think we're having a hard time hearing you, Jason. Sorry.
There we go. I didn't hit that button.
There we go.
These are a number of the partners that we've been working with on the R&D side with product available overseas. Some of our pre-production work. We've got some fairly large thermometric projects with significant national laboratories lined up coming down the pike. And learned a lot over the last 6 months and more doing some of this early work. We are going to market, most likely timber fill will be considered cellulose insulation as it is. And those standards are already laid out. The path is very clear for us with that product. Some nuance to work out with bat and board, but we have every confidence that we will be producing on time and delivering a code approved ESR with each one. And being the new kid, we've got a few stairs to climb as we get into the market, but we are well prepared to show up strongly with extensive testing when it comes to sound, fire safety, and code compliance. Additionally, for those that focus on LEED certification or declare or well, all of these additional certifications, we will be chipping away at those as well. Most likely we'll have a declare label in short order in 24, I would suspect. And a little bit as we get towards the end here, maybe just know that we're working on an extensive library of documentation for technical resources and more. Edith, do you want to say anything more about the last couple of slides here before we turn it over for questions?
Yeah, I'll just point out that we're launching a new website, hopefully next month, and that will really become an information resource hub for anybody with questions. So that's where we'll be storing wall details and installation techniques and all sorts of videos and resources. Answer any questions you might have. So that's very exciting. Definitely please sign up for our mailing list, because that is a great way for you to find out when all this is going to hit. Here we go, and definitely subscribe to our social channels as well. And there's a lot of great conversation happening, especially on Instagram and TikTok. And Claire Donnelly, who's here, is managing our social channels, and she's doing a great job and is bringing a lot of delight to the scene, I think. So definitely follow us and especially sign up for our newsletter, because that is, if you're looking for resources, we're rolling them out over time. We're working as hard as we can, as fast as we can. There's lots that we have right on the edge of being able to publish for you all. So definitely sign up there. And I guess on the last slide here, just want to let you know about our upcoming workshops. And so all of 2022, last year, we just had 101s every month, and we've had a great amount of people joining us. This is definitely the smallest group so far, so I hope you'll pop on and ask some questions. But looking at next month, yeah, we'll be talking a lot more about embodied carbon and this amazing tool that's called the Beam Calculator. It's a free spreadsheet, Google sheet, if you will, that will allow you to calculate your embodied carbon in your building. So that's something that Jacob has developed with his team, and it's incredible. It's free. Yeah, get your LCA data going. There's also other great programs that hopefully other people are already using, like Tally. But we're excited to talk more about embodied carbon. And then we are going to be developing our first AIA accredited presentation. So you'll be able to gain some credit in the near future. And I'll just point out, we've March and June, we have the great Joe Seabrick joining us, and we'll be talking about flow-through assemblies. Not sure what we'll be doing in June, but something riveting, I'm absolutely sure. And then the 18th is going to be a really fun one. Weatherization is sexy, not really, but we'll do our best. with John Riley. And that will actually be a live stream, hands-on demo. It's going to be a hybrid, remote, and in-person webinar. So that'll be a fun technical challenge, but you can come to the mill and be part of the hands-on demonstration, or you can sign on and it'll be also, you know, webinar geared towards the remote audience member as well. So I'll leave you with that, and please hit us with any questions you might have. Feel free to unmute and say hello.
I'm not sure who, if anyone has been following in the chat. I think Alex maybe has been answering some questions along the way. But if there's anything that has not been answered in the chat already, I can open that up and take a look. Feel free to, as Edith suggested, unmute and chime in. We'll do our best to answer on the fly.
Yeah, we
this
haven't
is-
done.
Yeah.
Oh, go ahead.
This is Pat Clark from Stoltz Timber Systems. We're in Northwest Montana. Is it too soon to ask for pricing lists? We are pricing projects on a regular basis. We supply cross-laminated timber packages, and would be great to start specifying your product rather than European product.
Sure. I would say feel free to reach out to us, info@timberhp.com. We'll start there and feed you to the right channels. We can give you some rough ideas. We are going to market. We'll be working through distributors, and the distance, of course, will not be handled by distribution locally, and we can certainly talk, Patrick, and get you something going. Another question out there?
Yeah, I've got
Great
one.
question. Sure.
Go ahead.
Hi, so this is Kat Young. I don't know if I missed it in the slides, but can you talk a little bit about the testing that has been done with regards to longevity and all of the, you know, amazing properties that the insulation has and how it works over time?
Sure. I mean, some of the standards that we will be complying with, we'll be basing our product, the loose fiber and the bat in particular, are going to follow the existing cellulose standard. Durability testing is done. I think it's ASTM 1338, and it's about mold growth, and that has to do with the chemical loading. So we're confident that we will have a product that meets that standard. When we talk about durability, we've done some unofficial testing, if you will, with European product. Our water table, the one we had shown in the video, we often just have a chunk of wood fiber soaking in that tub. And what we found over the months of standing water, which is not a good way to build your buildings, so they experience standing water, is that there's very little blowout or expansion of that board. It is absorbing some of the moisture, distributing it to some degree, but when we take it out and let it dry, it's still got a nice square edge to it, very little expansion. The product is not a structural product. It's not meant to control racking or any kind of loading, but it is compressive strength, very similar to XPS foam. So one of the advantages in a rain screen application is it's that durability and strength. Its lack of compressibility allows for quick installation. We, in the evaluation reports, will have that information. As we're not in production, we haven't done official testing on any of the material yet, just looking at prototype work right now. Hopefully that answers it for you. There is a question in the chat about sound. We will be producing thermal insulation and at full cavity fill for 2x4, 2x6, 16, 24 on center, steel frame and wood frame. And additionally, there will be an acoustic bat for most of those assemblies as well. The initial results that we've seen so far is that it is as I suggested earlier in the slides, a great performer when it comes to sound resistance. Just kind of scroll through and see if we've missed anything else. I know we're past the hour. I would say feel free to chime in and interrupt if you've got additional questions, but I'm mindful of everyone's time and appreciate you joining us today. info@timberhp.com. And that will get you to the right folks here. Alex has been doing a great job responding and also disseminating that information to others on the team. We are a small team. We are trying to be as responsive as we possibly can. It's been great to hear from folks, great input, and look forward to hearing from you. Anybody else have additional comments on the team or from the audience?
Jason, we just had one more question from Frank about if we have a coverage chart for the sill installation. I know this is going to be your favorite topic.
Oh, of course, Frank, you'd ask the hard questions. I can send you a coverage chart. We've got some preliminary data, I'll say. We expect very little variation, but I'm a little shy of sending that out until we get our own fiber dialed in, of course. But as far as coverage, expected to be fairly comparable to most of the major cellulose manufacturers out there. I'll try and reach out to you directly after the call here. We can talk about it further if you like. But yes, we will have that out shortly. We've got a preliminary one that we can share to give you a rough idea. I expect the density in the walls to be a little bit lighter than what we've found with cellulose, so greater coverage in a wall. But attic should be about the same per square foot, same kind of coverage. Excellent. I'm going to call it almost 10 minutes over. Thank you so much, everyone, for joining us. Please look forward to future events. Check with us with all the social channels. And if you don't know how to use those, ask your kids. There's good content, wonderful stuff that's being produced out there by our team. So proud of everyone and all the work that we do here, and looking forward to providing you wood fiber installation here coming up real soon.
Bye.
Thank you all so much.
Thanks, everyone.